Good morning all. Today's class is about Newton's forward and backward interpolation. Now what is interpolation? Interpolation is the process of finding the intermediate values of a function when you are given a range of values for that function. So to find the intermediate values of a function using the given set of or tabular values of that function. That process is called interpolation. In this video, we will be seeing Newton's forward interpolation and Newton's backward interpolation formula and how it is used to find the intermediate values. So let's consider a function y equal to f of x, which takes the values y0, y1, y2, etc. till yn for the equidistant values x0, x1, x2, etc. till xn. So Newton's forward interpolation and backward interpolation formula are used for equidistant values of x0, x1, x2, etc. till xn. So the equidistant values means that the consecutive arguments will be having the same interval of differencing. So here h is the interval of differencing. Then y0, y1, y2, etc. till yn are the entries. x0, x1, x2, etc. till xn are the arguments. Now Newton's forward interpolation formula is phi of x is equal to y0 plus delta y0 by h into x minus x0 plus delta squared y0 by 2 factorial h squared into x minus x1 into x minus x0 plus etc. till delta raised to n y0 by n factorial h raised to n x minus x0, x minus x1, etc. till x minus xn minus 1. So in the nth term you have to subtract till xn minus 1 from x. n minus 1 terms will be included. Now look at the differences. Here you can see that we have in each term we have y0, delta y0, delta squared y0, etc. till delta raised to n y0. These are the leading differences from the forward difference table. So in Newton's forward interpolation formula, the leading for differences of the forward difference table are used in this formula. Okay, so this is the Newton's forward interpolation formula. Now we have a simpler form for this formula, and that is obtained by substituting this x minus x0 by h with u. So by substituting x minus x0 by h with u, you will get a simpler form of the formula, and this is a simpler form, that is phi of x, where now x becomes x0 plus hu. It is obtained from this u equal to x minus x0 by h. From by simplifying this, you will get a value for x, that is first we will multiply h to u, you will get hu. Then putting this x0 to the left side, we will get x0 plus hu, which is equal to x. So phi of x, instead of phi of x, we can write phi of x0 plus hu. Now the formula is transformed as y0 plus u delta y0 plus u into u minus 1 by 2 factorial delta squared y0 plus u into u minus 1 into u minus 2 by 3 factorial. When there are 3 terms here, 3 factorial will be divided with that term, and the difference will become delta cube y0. See, in the second term there were 2 factors in the numerator, and it was divided by 2 factorial, and delta squared y0 was used. So in the nth term you can see that there are n terms here starting from u, then and divided by n factorial, and the difference is delta raised to n y0. So this is a simpler form of Newton's forward interpolation formula, and this will be used in the formula in the problems where you have to find the intermediate values. Okay. Now let's see Newton's backward interpolation formula. So Newton's backward interpolation formula is, in backward interpolation we will be using the backward differences. So there, instead of delta we will be using del. So in the backward difference, the leading differences are yn, del squared yn, del etc. till del raised to n yn. So these differences will be included in Newton's backward interpolation formula. And another difference is that in forward interpolation we subtracted we started with x minus x0, then in the next term x minus x0 into x minus x1, like that it was going. Now in backward interpolation, instead of x0 here xn. So x minus xn, in the next term x minus xn into x minus xn minus 1. Likewise in the nth term it will reach till x minus x1. Here the difference is that in forward we will be using x0 like that, and in a backward it will be based on this n. So in the backward interpolation formula, phi of x is yn plus del yn by h into x minus xn plus del squared yn by 2 factorial h squared into x minus xn into x minus xn minus 1 etc. till del raised to n factorial h raised to n x minus xn, x minus xn minus 1 etc. till x minus x1. Okay, so this is Newton's backward interpolation formula, and the simpler form for this formula is obtained by substituting this x minus xn by h with p. So phi of x becomes phi of xn plus hp, which is equal to yn plus p into del yn plus p into p plus 1 by 2 factorial del squared yn plus, here we'll have one more factor, right? So p into p plus 1 into p plus 2 by 3 factorial into del cube yn plus etc. So this is Newton's backward interpolation formula. So these are the formulas which we are going to use to interpolate a value, the value from a given set of values. Now let's consider the given question. We are given the values of tangents and we have to find tan 0.12 and tan 0.26 from the given set of values. So the first step is you have to construct the difference table, because the same difference table is used for forward and backward interpolation. So first we will construct the difference table, and then we will find the values for 0.12 and 0.26. The table headings of the difference table are: first you have to write the arguments, that is the x values, then the entries, that is the y values, and the differences. So after writing the x values and y values, first we have to find the first difference, first forward or backward difference. So this is obtained by subtracting the entry values, the consecutive entry values, and it should be written in between these two values. So the first entry value, first difference is obtained by subtracting 0.1511 minus 0.1003. That is what is written here. We get 0.0508. This is the first value of the first difference. So this here I have written delta y. This is also same for del y, because in del y also we will be finding the difference between these two, and that also y1 minus y0 will be found. So we will get the same value. So for the forward and backward difference table, the values will be the same. So we need to construct only one table for forward and backward difference table. Okay. Now we'll find after that find out all the values for the first differences by subtracting the consecutive values of the entries. So the second value will be obtained by subtracting these two, that also by subtracting 0.2027 minus 0.1511. The next value will be obtained by subtracting 0.2553 minus 0.2027, and it should be written in between these two numbers. Now this also, then we'll get the last value for the first forward or backward difference. So these are the values obtained for the first differences. Now using this you can find the second differences. So the second difference is delta squared y or del squared y is obtained from the first differences. The first value is 0.0516 minus 0.0508, and the result obtained should be written in between these two numbers. That's why I have written it here. Then the second value will be obtained by subtracting these two values, and it should be written in between the space in between these two numbers. Likewise, you will get all the values for the second differences. Now to find the third difference, it is obtained by subtracting the values of the second differences. So by subtracting these two, you will get the first value, and by subtracting these two, you will get the second one. Then after that, again since you have two values for delta cube y, we can go for delta raised to 4 y also, and delta raised to 4y is obtained by subtracting these two. Now in delta raised to 4y we have only one value, so we can't go for delta raised to y, 5y. Okay, so this is the difference table that we will get after finding all the differences. Now we have to find the value of tan 0.12. Remember that we can use the same difference table for forward and backward interpolation. The only difference is that in forward interpolation, the leading differences are the first values of the differences. The leading differences used in the forward interpolation formula are the first differences in the are the first values of the differences in the table. So these values will be used in the forward interpolation formula, and in the backward interpolation formula, the leading differences used are the last values of the differences. So these values will be used in the backward interpolation formula. Now we have to find the value of tan 0.12. Now look at the table. In the arguments, you can see that 0.12 comes in the beginning of the table. That means we have to use Newton's forward formula. So remember that, or take note that Newton's forward formula is used to interpolate values which are at the beginning of the table, and Newton's backward interpolation is used to interpolate the values which are near the end of the table. So since in this question we can see that we have to find tan 0.12, it comes in the beginning of the table. That means we have to use Newton's forward interpolation formula to find the value of tan 0.12. So let's use the Newton's forward formula. The Newton's forward formula is phi of x is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial delta squared y0 plus etc. by u equal to x minus x0 by h. So we have taken the second formula, that is the simpler formula of Newton forward interpolation. Now in this, first we have to find the value of u. Only then we can substitute that in Newton's forward formula. So to find the value of u, formula for u is u equal to x minus x0 by h. Here x is the value for which we have to find the x is the value for which we have to find the result, that is we have to find tan 0.12. So x is equal to 0.12. Then x0 is the first value of the argument, that is 0.10, and h is the interval of differencing. So taking any two consecutive arguments, you can find the value of h. So the value of h we get is 0.05. Now you have all the values of the variables for which has to be used to find u. So substituting in this equation, we will get the value for u, that is u equal to 0.12 minus 0.10 by 0.05, which is equal to 0.4. So the value of u that we got is 0.4. Substitute that in Newton's forward formula. So while substituting, we can see that phi of x, here x is 0.12. Phi of 0.12 is equal to y0 plus. Y0 is the value of y when x is equal to x0. That is the first value of y, which is 0.1003. So that is substituted here. Then plus u into delta y0. So what the value of u is 0.4. So substitute 0.4 here into delta y0 is the first difference, first forward difference. So just if you mark the leading forward differences like this, then it will be easy for us to make the substitutions. So delta y0 is the first value of delta y. Substitute that here. Then plus. Next term is u into u minus 1 by 2 factorial. So u is 0.4. 0.4 into 0.4 minus 1 by 2 factorial into delta squared phi. So just take the second value in this rectangle, yeah. Then the next term is, here we have taken in the delta squared y0, the coefficient is u into u minus 1 by 2 factorial. So the next term will be u into u minus 1 into u minus 2 by 3 factorial, where u is 0.4, so 0.4 into 0.4 minus 1 into 0.4 minus 2 by 3 factorial into delta cube y0. So just take the next value. So substituting that, we'll get this. Then the next term, since we have delta raised to 4y, so we have one more term. That means in this term here we have 4 terms in the numerator divided by 4 factorial. So it will become u into u minus 1 into u minus 2 into u minus 3 by 4 factorial into delta raised to 4 y0, which is 0.002. So after simplifying this, you can use calculator to find the answer of phi of 0.12. So using the calculator, you will get the value 0.1205. So this is the value of tan 0.12. So this way you can find the next value or next question also. The next is tan 0.26. So when you get a question after constructing the difference table, just look where this x value lies. Here we have 0.26. In the table you can see that 0.26 comes here. That means it is near the end of the table. So if you are going to interpolate a value near the end of the table, you have to use Newton's backward interpolation formula. So this is considered when if the arguments are at equal distance, that is equidistant or equal interval. So Newton's forward and backward interpolation are used when for arguments at equal intervals. Okay. So in the case of tan 0.26, we have to use Newton's backward interpolation formula, which is phi of x is equal to yn plus p del yn plus p into p plus 1 by 2 factorial del squared yn plus etc. where p equal to x minus xn by h. So here x is 0.26. Then xn means it's the last value of the argument. So looking at the table, you can see that xn is 0.30. Substituting that 0.30 and h we have already found, which was 0.05. After substituting these two, evaluating, you will get ps minus 0.18. Okay, now we have to substitute it here. So therefore, to find phi of 0.26, of the first term is yn. Yn is the last entry value, that is 0.3093. 0.3093 plus p into p is minus 0.8 into del yn. Del yn means it's a leading backward difference, the first difference. So it's better to mark the leading backward differences with a rectangle, so that you can just use the values one by one in each term. So del yn is 0.054. So it will be substituted here. Then the next term is, here p goes by adding, right? So p, if we are here we have used p, the next term will be p into p plus 1 by 2 factorial. Next will be p into p plus 1 into p plus 2 by 3 factorial, and so on. So here we can substitute for the value of p is minus 0.8. So just write it like as such, minus 0.8 into minus 0.8 plus 1, that is p plus 1 divided by 2 factorial into del squared. The value of del squared is the last value of second difference, that is 0.0014. that is substituted here. Then the next term will become p into p plus 1 into p plus 2 by 3 factorial into del cube yn, and the last one p into p plus 1 p plus 2 p plus 3 by 4 factorial into del raised to 4 yn. So those values are obtained here, del cube yn and del raised to 4 yn. Evaluating this, you will get the answer as 0.2659. So this is how Newton's forward and backward formulas are used for interpolation.